Okay, and we're back. As a reminder, here are 5 equations to know for the worksheets or the practice problems that we will be going through for our acid and base worksheet. And then here are some of the questions that we will work through. If we recall, pH plus POH equals 14. Okay, so if we have a pH of 7, 7 plus 7, or 7 plus X equals 14. Therefore, X is going to be equal to 7. If we have a pH of 3, 3 plus a number equals 14. And therefore 3 plus 11 is going to be equal to 14. And so don't try and make those questions hard whatsoever. They are that simple. Just pH plus POH equals 14. Now for this next one, the equation that we will be using for this is pH equals the negative log of the concentration of the hydrogen ion. Okay, and so this value right here, the 4.5, that is our concentration, and so we just simply put that in there. So the pH is going to be equal to the negative log of 4.5 times 10 to the negative 3, and there we go. And so now we got to look at this. Is this an acid or a base? This right here, this has a hydrogen ion that will drop off. And how do we know that it's going to be an acid? It's because it has this hydrogen ion. Okay, so it will be an acid. Therefore, we are looking for pH, and we don't have to do conversions up here. Oops, pH plus POH. My bad. So let me just write this one again. pH plus POH equals 14. Okay. All right, so now we put this in our calculator correctly. Here we go. If you are running a Texas Instruments calculator, this is how you do it. So you are going to hit the negative button, not the subtraction button, but the negative button. And then you see the log. The log button is right here. Okay. So negative log, and then you see the bracket there. We have the beginning parentheses. That right there. 4.5. Don't forget your exponent. Second, double E. And then we have a negative 3. So negative 3 end parentheses. Just like that. And then you hit enter. And that is your pH, 2.34. Or we're only going to go out 2 digits. So this will be a 2.3 pH. That is our answer. Okay. Now let's look at the next question. 3.67 times 10 to the negative 5th molarity of potassium hydroxide. Okay, this is an OH. So is this going to be a base or is it going to be an acid? The H over here indicated acid. Therefore, the OH, same as that OH, is going to indicate that it is a base. Okay. So now we are going to find our OH value, and then we're going to put it back into this equation here. Okay, so the equation that we're going to use is POH equals the negative log for the concentration of OH ion, just like that. And so we put it in our equation. equals a negative log. Our concentration right there, 3.67 times 10 to the negative fifth. And away we go with that. We're going to plug this back into the calculator. Okay, so once again, hit the negative button for the negative log. Don't forget the negative log. You will get some numbers that you're not expecting. Hit the negative log and then 3.67 second double E key -5 end parentheses, and you get this number right there, 4.43. And so remember, this is our POH. So our POH equals 4.43. This time we're doing 3 digits because we were given 3 digits in the beginning. This other one, we only went 2 digits because we were given 2 digits. Okay? And so now POH is 4.43. We're looking for the pH from the original question. So now we have to involve this. pH plus POH equals 14. So we're going to plug these numbers in. 4.43 equals 14. So pH plus that value equals 14. And so as we subtract 4.43 from 14, we get a pH value of 9.57. And that becomes our answer there. Okay? Now on to the next. A solution of 6 molar hydrochloric. Is this an acid or a base? Look at your hints. We have the hydrogen there without the oxygen next to the left of it. So this is going to be an acid. Okay. Solution is 6 molar acid, so we get to use pH equals negative log concentration of H. So pH equals negative log concentration of 6.0. Don't have to do all of the exponents and the double E key with this. I can just simply put this in, negative log 6.0 end parentheses, and there we go. As you notice, this pH is different from what you are expecting. This is a negative value, and that is okay. It's not normal to have a negative value, but it is possible. So our pH is equal to 0.78. Negative 0.78. We're only going to go 2 digits because we only have 2 digits there. Okay? Now we need to determine the POH. That's what we did here, right? Okay. So we have NOH. Is this an acid or a base? What is going to separate? Is the hydrogen going to separate, or is the OH going to separate? Well, if we finish with OH, that's our biggest hint. This will be a base, so we're going to find the concentration of OH. Negative log the concentration of OH. So POH equals negative log 1.5 5. So we put this in our calculator. Negative. Clear that out so you can see it. Negative log 1.5 in parentheses. And our value is negative 0.176. Once again, we use it. It's not normal, but we use it. POH equals negative 0.176. So we're going to round this to an 8. Okay. And then our final question. 6 molar solution of HCl. This time we're looking for POH. Previously, if you notice, we just found it up here. For pH. Now we're finding POH, the same concentration. So we've got 2 different ways to do this. We're just going to check our work and see how we get there. Okay, so according to our equation, pH plus POH equals 14. We insert this negative 0.78 plus POH equals 14. That tells us that our POH should be equal to 14 minus a negative 0.78. That tells us 14.78. Should be our POH. Let's do this equation the other way and find out. So our POH is what we're looking for. We're going to find the pH because this is an acid, and then we'll move on the other way. pH equals a negative log concentration of H. So pH equals negative log 6.0, and that, as we put it in our calculator, we already found out equals negative 0.78. Okay. And then we go to there. You guys have a great day and enjoy practicing these worksheets. We'll see you later. Bye.